All right, here's an application problem for exponential decay. Here's what we give you. A radioactive substance decays exponentially. A scientist begins with 100 milligrams of a radioactive substance. After 35 hours, you have 50 milligrams left of the substance. How many milligrams will remain after 54 hours? This is a multi-step problem. I'm going to go ahead and write down the equation. Y equals a b to the x. This should look familiar to you now. And it's an exponential decay, so we know the graph is going to decrease over time. Okay, so let's go ahead and identify some important pieces in the word problem. So we start off, this is our initial value of 100 milligrams. Then, after a certain amount of time, this is what you're left with, 50 milligrams. And the time is 35 hours. So if we substitute in, remember this represents your left-hand side, is your end amount. A is your initial. Have your multiplier, and then you have your time. So let's go ahead and substitute those values in. So our end amount was 50 milligrams. Our initial was 100 milligrams. We have some base, and then raised to 35 hours. And what we want to find out is what is the b. So we're going to go ahead and solve this for b. So we're going to go ahead and divide both sides by 100. So we have b to the 35. 50 divided by 100 is 0.5, or 1/2. And now we need to undo that 35th power. So to undo a 35th power, this looks kind of crazy, but we're going to 35th root both sides. Because right now we have a power of 35. Now, I'm going to go ahead and take my graphing calculator. I'm going to put it up over here. Depending on what kind of calculator you have, I'm going to show those who have the graphing calculator. You want to go ahead and put the 35 in first, okay? So that's telling you 35. You're going to go to math. You're going to scroll down to number 5, where it has the x and then the square root, but that really means we're taking the 35th root. So that x is your root number. So now you're saying 35th root of, and then our value is 0.5. So we'll go ahead and put our 0.5 in. And we enter it, and we'll get our value of approximately 0.980. So let's go to 3 significant digits here. So our b value is approximately 0.980. All right, go ahead and scroll my graphing calculator off to the side here. I'm going to head back up. All right. So now, if you remember, y equals a b to the x, we can go ahead and write out what this equation is. Y will be your initial or your end amount. A, remember when that was your 100 milligrams. Now we're going to go ahead and throw in our decay rate multiplier of 0.980, and then x represents our time. All right, now we're set to answer the last part of the question. We want to find out how many milligrams will be left if we continue on to 54 hours. So 54 is now our time. We're going to go ahead and substitute that in. So y equals 100, our decay rate multiplier, and then 54. Now you're going to want to use your calculator again, so I'm just going to show you how you use that. I'm going to clear out my screen. So now you put 100, parentheses, 0.980, parentheses, and now you're going to raise it to, so you're going to do your little caret symbol, we call that, and then 54. And we'll get approximately 33.589. 89, so that's going to round up to 90. Okay, milligrams left after